Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, and in this session, we'll be showing you the new turning option in SolidCAM 2011 of face. We'll start by going into operations of turning, and as you can see, we have three new operations. We have an operation just for face cutting. We have an operation for undercut grooving, and we also have a separate operation just for cutoff. Let's first start by taking a look at our face operation. Now, as you can see in general now, our interface has been completely improved and a lot easier to read. For example, as you can see, we have now diagrams or actual pictures showing us exactly what we'll be doing. For example, here we see we'll be doing face mill. If I were to go, for example, into technology and click into this field over here, you can see we're talking about an offset. Retract value, distance, retreat distance, rough cuts, everything has an illustration next to it. Let's go into geometry, and first we'll talk about this option over here. This shows us whether our retreat point will be to the right or to the left by clicking on whichever side you feel necessary. Next, we also have our submachine, which contains a main spindle and a subspindle. For example, if we were to take a machine like the Integrex, for example, it is based on the B-axis and the main spindle, or the B-axis and the subspindle, or also known as the back spindle. All of this is defined in our ID machine. Let's take a look for a moment at the ID machine, and I'll go out of this operation for a moment. If we go into our machine ID, you can see that we have here our submachine. The submachine is based on the turret and the table. For example, our main spindle is based on the turret and our main spindle, and the subspindle is a combination of our turret and our subspindle. And this can also be seen as we click on main spindle, and we see here turret and main spindle, and our subspindle, which shows us the turret and the sub. Now let's go back into our operation. So as I said, we'll be cutting from the right hand side, and we'll be using the main spindle. Now we've also added another option here called modify geometry, just like we have in our milling operation. Let's first go into define to define our geometry. And what I want to do is actually cut this face as shown over here. So I'll click on define, and I'll choose this line over here, and I'll accept that. Now let's go into our modify geometry. In modify geometry, we have here now the options of start extension and end extension. We can either put a value over here, as shown over here, or I can click on auto extend to stock. This is a huge improvement of what we've had before, because now it automatically goes to exactly where the stock is without having to guess where that stock is. Now, we can either do this on tangential, as shown over here, where it moves tangential to the next area, or we can go to linear. Linear is I actually define the actual angle I wanted to work its way into the part. I can say 90, I can say 0, I can say 30, I can say whatever one I want. In this particular case though, I'm just using tangential. And we have the same option as far as our end extension. Now in addition, we've also added the option of giving an offset to our geometry, as we can take our geometry and physically move it to the side. So say if I wanted to have an offset of 5 millimeters, you'll see my geometry had been moved out now by 5 millimeters. I'm going to put it back though at 0. Next, I'm going to choose my tool, and in this particular case I already have a tool here created, so I'll just select that tool. Now, as we see in this picture on the bottom, the diagram shows us this is exactly how the tool will be lying in the machine. Now, since I want to come from the top down, I want to have it as shown in this diagram over here. So I simply click over here, and this will automatically change to that position. Now we've also done away with a lot of the buttons that we had on the bottom over here, and we've added them to tabs instead, such as the origin position of my insert, the data, and let's go into coolant for a moment. And as you can see, it shows us what coolant is supported by the machine with the check mark. those that have a check mark next to it are the ones that is supported. And this is defined in our machine ID. Let's go now into our technology field. And in our technology field, this is exactly what this operation can do. We can have the working area from the stock, or we can actually do extended stock buy, where we'll not even look at the stock itself, and I can actually go on further or less. I can work from the front, or I can work from the back. The direction I can either do one way or zigzag, as shown in the diagrams over here. Now, in my rough cut area, we can have our equal step over, how much it's going to step over each time, and I'm going to set this at 0.8 millimeters. In addition, however, we've added the option of final step, where the last step I can say, I only want you to go in 0.2 millimeters, and the number of those steps. I'm going to leave it at 1 step. I can also click on finish for a finish cut. And on my finish cut, if I want an offset, I can have an offset of 0.1 millimeters. Let's do save and calculate, and let's take a look at the results. If I were to run my simulation, you'll see that my tool has gone in, and let's take a closer look. We see that it cuts every 0.8 millimeters. However, the final cut is only 0.2 millimeters in width. Now, you'll also note, though, that there's no extension on the final cut. There's no lead in. What we've done now also is that we've made an improvement in our links. Not only do we have an approach point, but we also have a retract point. And we have our finish lead in and finish lead out. Let's click on finish lead in, and we'll choose the option of tangent. And as you see over here, I can add a tangent of, say, 20 millimeters. Now I'm choosing 20 millimeters, even though it's large, just so that we can actually see it very clearly in our simulation. Now let's go into save and calculate, and again look at our simulation. This time, as you see, we have our cuts, but our final cut, the 0.2 millimeter cut, has now been extended tangent by 20 millimeters. So it can go in from above the part itself. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.